Hi, it's Mr. Halliwell here. In this particular video, we're going to have a look at the present value, but specifically for loan type questions. Okay, so in the previous video, all the present value questions were investment related, but we're going to have a look at loan in this video. Just a quick recap of the last video. If we have an investment that is an annuity, the present value of the annuity is the single amount of money or the lump sum that, if invested now, would produce the same future value as a given annuity. Okay, so it's one amount that you could invest now that would produce the same amount as the future value of an annuity. Okay, and we saw last video that this is calculated very easily using a present value table. We just take the contribution and we times by the table factor. Okay, in this video, we're going to focus on present value when we've got a loan type question, or it can also be applied to the if you're withdrawing from a lump sum. So an example of withdrawing from a lump sum is, imagine you want to retire. You've been putting a lot of money into your super and you want to retire. So you often take that money out as an annuity. You've got a big lump sum there initially that you've been putting into your super, and then you take out a certain amount every, say, fortnight to live off. Okay, so think of this withdrawal from a lump sum as a retirement annuity type question. Okay, the nice thing about these particular questions is you use the exact same table, you use the exact same method. The only thing that's different is the interpretation of what exactly you are calculating. Okay, so for an investment type question, we think of the PV as the lump sum that you could invest now to give the same future value. But loans are different because eventually you pay off the loan at the end. It's a bit different. So what is the present value of an annuity for a loan or a lump sum? Well, this is the way we interpret it. The present value of the annuity for the loan is equivalent to the original or loan amount or the original lump sum amount. Okay. So that's the interpretation. If you have that interpretation in your head, you'll be able to do all sorts of questions. Let's do two examples here. So present value of annuity table, we're going to be using this one. Here's the first question. A retiree has P dollars in the bank on the 1st of January, and on the 31st of December each year for the next 20 years, so 20 times, the bank pays him a pension of 40 grand from the account. So use the present value table to calculate P. So basically, we want to work out the amount that the retiree had at the beginning. Right at the beginning, before we started taking out those 40 grand at the end of each year. Okay, so this P is actually going to be my present value. It's going to be how much is in my account now, so that for the next 20 years, at the end of the year, I can take out 40 grand. Okay, that 40 grand is going to be the payment amount. Okay, so now let's see, we're compounded annually and the interest rate is 4.5%. Okay, everything compounded annually means everything annually, which is nice. So R is going to be 4.5%. I don't need to change R, and my N is 20 years. Okay, I don't need to change that. So we're looking at the table. We find our table. So period of 20 and R of 4.5. We go across to 4.5 R. There we go. The table value that I like to write down. You write table equals 13.0079. Okay, and to work out P, the present value, it's going to be the payment times the table factor. Okay, so here the present value is P, the payment is 40 grand at the end of each year, and we're timesing it by the table factor, 13.0079. Okay, when we put that into a calculator, we get 520,316. All right, let's do a quick sort of logical check in our head. Is this kind of a reasonable answer? Okay, so basically this $520,000 is basically how much this retiree has at the beginning of their retirement, and apparently they can get 40 grand for 20 years off that amount. So they can get 40 grand for 20 years. So if you do that, that's 800,000. So you might be thinking in your head, how can you get paid 800,000 from 520,000? Well, there's interest, right? Your $520,000 is constantly gaining 4.5% interest over time. So that $80,000 will be made up of your 520,316 plus whatever interest. And because we've got a lot of money in there and we're only withdrawing a small amount, 40 grand each year, it makes sense that the interest will be quite large. So interest of about 280,000. Yeah, that is reasonable. Yes, it's reasonable. Okay, so always for these questions, sort of check that your answer's in the right sort of ballpark. If I would have got an answer of, say, 100,000, well, if I'm taking out 40 grand, I'd only expect it to last me about 3 years, not 20 years, okay? So you have to get a reasonable kind of answer. Is my answer reasonable is always a good question to ask in these sort of questions. Let's move on. Next one. Brandon buys a car for 80 grand, deposit of 32 grand, loan of 48,000. The most important thing is to look at the loan amount. That'll be your present value. The other ones I don't care too much about. They might pop up later on in the question. But the key thing is your loan amount is your present value. The loan is paid off 5 years, 6% per annum compound interest, and it says with annual compounding. So find the installment if he pays annually. So the installment is the payment. So if you ever want to find the payment or the installment, rather than timesing, we're going to be dividing. Okay, so that installment is going to be the present value divided by the table. All right, so let's work out what the table factor is. So we've got N of 5 years, and the R value is 6% per annum, and everything's compounded annually, so that stays. So N is 5, R is 6%. N is 5, period of 5, and we've got 6%. That'll be this number here, 4.2124. I always write down my table value because occasionally the HSC markers give 1 mark just for writing down that table value. 4.2124. It's my table, and my PV is going to be my loan amount, 48,000. So the installment's going to be 48,000 divided by 4.2124. Okay, put that in my calculator, and I get that my installment amount is going to be 11,394.93. Okay, that's how much I'm going to be paying back every year. All right, per year. It's my installment per year. Okay, part 2. Find the installment. If we pay monthly rather than yearly with monthly compounding. So we're changing everything to monthly. So the first thing is I'm going to change N from yearly to monthly. So I'm going to times by 12. N is 60. And my R, I'm changing it from yearly to monthly. So I need to divide by 12. I'll get 0.5%. So I'm looking for N is 60, 0.5%. So N is 60, period of 60, 0.5%. There it is, 51.7256. 51, so I'll write table, 51.7256. Okay, so my installment, I'm not going to rewrite the formula. We're going to go straight to the PV, which is 48,000, divided by my new table factor. Okay, and when we put that into our calculator, you should get 927.97. And because our installments are now monthly, that'll be per month. That's part 2 done. Part 3. How much more will the first method of repayment cost him? Okay. Well, it's important to note that no matter which method you use, you still pay that 32,000 deposit. So we can essentially ignore the deposit, and we'll just focus on the loan here. So so the first question, we're paying yearly, and we're paying for 5 years, and we're paying this amount, 11,394. So let's go part 3. Let's do, I'll write yearly, so I know it's yearly. the total paid, total on loan, I'll call it, total on loan is going to be the 11,394.93 times by, we make 5 yearly payments of that amount, and that's 56,974.65. Okay, well, that sounds reasonable to me because my initial loan was 48 grand and it's going to get some interest, so I'm going to pay back more than 48 grand. So that's the yearly amount. Now let's do the monthly. So the monthly total on loan is going to be the monthly installment amount, which is $927.97. Now, that's per month. There are 12 months in a year, and then there are 5 years that I'm paying back this loan. So when I put that in my calculator, I get 55,678.20. And to answer the question, it says how much more is the first method. So the first method is more, the yearly method is more. How much more? First method is, we're going to minus, just take the first number and minus the second number. 55,678.20, and put that in your calculator. I get $1,296.45 more. Okay, and I'm going to answer in words to make it very, very clear. All right. So you might be wondering why the yearly was more than the monthly. Well, it should make sense in your head. For monthly, you're paying more regularly. And because you're paying off that loan more frequently, the amount you'll pay back in total will be less. Okay, you're knocking off that principal earlier. And so you're going to pay less interest. Okay, so the more frequently you pay a loan back, the quicker you pay off the loan and the less total you'll have to pay back. Okay, and that was significant, over $1,000 just by changing from yearly to monthly. Okay, all right. What I want you to do, there was no loan questions in your textbook, despite there being lots of loan questions in the past HSC. So what I've done is I've gone to another textbook, Oxford Insight. Okay, so this is on page 9 of your notes. I want you to use the table from page 8, so previous page, page 8. To complete the exercise, okay? So 7C, just 3 questions, 8, 9, 10, and 7D, those 4 questions, 2, 4, 5, and 8, which are on page 9, okay? Good luck with that, and I'll see you in the next video.